In today's fast-paced digital world, smooth and efficient networking has become an absolute necessity. Welcome to the fascinating world of network engineering. Our focus today will be on two pivotal concepts in this realm: Layer 3 switching and Inter-VLAN routing. These terms might sound like technical jargon, but once you delve into them, you'll appreciate their profound impact on our digital lives. Let's start with Layer 3 switching. In the grand scheme of networking, this is a relatively new concept. It's a technology that combines the speed of Layer 2 switching with the benefits of routing done at Layer 3. In essence, it's about making data transmission faster and more efficient. Imagine driving on a highway with multiple lanes, all moving swiftly. That's Layer 3 switching for you, a highway for data, ensuring it gets to its destination in the quickest possible time. On the other hand, we have Inter-VLAN routing. Now, VLANs, or virtual local area networks, are like isolated islands in a big ocean of network. They allow us to segment our network into smaller, more manageable chunks. However, these VLANs cannot communicate with each other natively. This is where Inter-VLAN routing comes into play, acting as a bridge between these islands, enabling them to communicate. It's like having bridges connecting different islands, ensuring smooth and efficient traffic flow. Together, Layer 3 switching and Inter-VLAN routing contribute significantly to enhancing network performance. They not only ensure faster data transmission, but also provide efficient management of network traffic. Whether it's streaming your favorite movie, conducting an online meeting, or playing an online game, these technologies are working behind the scenes, making your digital experience seamless and enjoyable. Remember, these concepts are more than just theoretical constructs. They are the backbone of modern networking, and knowing them in depth can make you a better network engineer, capable of designing and managing high-performance networks. So, by the end of this video, you will have a deeper understanding of these two critical networking concepts. To kick things off, we will delve into the world of Layer 3 switching. What is Layer 3 switching, you may ask? Well, simply put, it is a technology that combines the speed of Layer 2 switching with the benefits of routing. Its job is to provide a faster and more efficient method of data transmission compared to traditional routers. Let's take a step back and consider the network layer of the Open Systems Interconnection, or OSI model. This is the third layer, hence the name Layer 3. Its primary function is to determine the best path for data transmission. Herein lies the brilliance of Layer 3 switching. It brings in the routing capabilities of Layer 3, but it does so at the speed of a switch, which operates at Layer 2. This results in a powerful combination of speed and flexible data transmission. So how does Layer 3 switching accomplish this? It uses hardware-based switching and high-speed silicon chips. Traditional routers, on the other hand, rely on software and microprocessor-based architecture, which can be slower. Layer 3 switches, therefore, are able to handle large volumes of data and are often used in situations where a network has a lot of traffic, like in large corporations or data centers. Another fantastic aspect of Layer 3 switching is its ability to perform IP routing. This means it can move packets between different subnets, which isn't possible with a typical Layer 2 switch. This is a crucial function as it allows for better traffic management and segmentation within a network. In essence, Layer 3 switching offers the best of both worlds. It provides the speed of a switch with the routing capabilities of a router. This powerful combination allows for faster and more efficient data transmission, especially in networks dealing with large volumes of data. Layer 3 switches, therefore, provide an effective solution for dealing with large volumes of data traffic in a network. Now that we understand what Layer 3 switching is, it's time to delve into how to configure and verify it. First things first, to configure Layer 3 switching, you will need to create a VLAN and assign an IP address to it. This is done using the interface VLAN command followed by the VLAN number. Afterward, you assign the IP address and subnet mask using the IP address command. Once you've done this, you can enable the interface using the no shutdown command. Next, you will need to configure a default gateway. This is done using the IP default gateway command followed by the IP address of the default gateway. This is a crucial step as it allows your switch to communicate with devices on other networks. Now, to verify your Layer 3 switching configuration, you can use the Show IP Interface command. This will display all the interfaces on your switch along with their IP addresses and statuses. Make sure that your VLAN interface is up and has the correct IP address. You can also use the Show IP Route command to verify that your switch has the correct routing information. This will show you the default gateway and all the routes that your switch knows about. During the configuration process, you might run into a few common issues. For instance, if your VLAN interface is down, it might be because the VLAN doesn't exist or there are no active ports in the VLAN. You can troubleshoot this by checking the output of the Show VLAN command. Another common issue is that the switch can't reach the default gateway. This could be due to a wrong IP address or subnet mask. You can troubleshoot this by pinging the default gateway from the switch. Lastly, if your switch doesn't have the correct routing information, it might be because the default gateway is not set correctly. You can troubleshoot this by checking the output of the Show IP Route command. With these steps, you can successfully configure and verify Layer 3 switching in your network. Scene script. Next up is Inter-VLAN routing, an essential part of modern networking. Inter-VLAN routing, as the name suggests, is a technique that allows devices from different VLANs or virtual local area networks to communicate with one another. This might sound like a simple task, but in the realm of networking, it's an operation that requires a keen understanding and careful management. Let's break it down a bit. A VLAN is a logical grouping of devices in the same broadcast domain. By default, devices within the same VLAN can interact with each other, but they cannot communicate with devices in different VLANs. This is where inter-VLAN routing comes into play. It acts as a bridge, enabling traffic to flow between different VLANs. Now, you might be wondering, why do we need inter-VLAN routing? Well, it's all about network performance and security. In a large network, having all devices in a single broadcast domain can lead to excessive traffic, slowing down the network. By dividing the network into smaller VLANs, we can reduce traffic. But we still need these VLANs to communicate with each other, and that's where inter-VLAN routing shines. Inter-VLAN routing also enhances security by isolating sensitive traffic in separate VLANs. For instance, you might have a VLAN for your finance department and another for human resources. With inter-VLAN routing, you can ensure that these departments can communicate when necessary, but their traffic remains separate and secure. Furthermore, inter-VLAN routing provides flexibility. It allows network administrators to manage traffic flow according to the organization's needs, whether that's limiting certain types of traffic between VLANs or prioritizing specific data flows. Remember, the ability to manage and control traffic between different VLANs is not just a nice-to-have feature. It's a fundamental aspect of network administration. Understanding inter-VLAN routing is critical for managing complex network environments effectively. As we delve deeper into the world of networking, the importance of techniques like inter-VLAN routing will become even more apparent. So, keep learning, keep exploring, and let's continue to demystify the world of networking together. Armed with an understanding of what inter-VLAN routing is, we can now explore how to implement and troubleshoot it. To begin the implementation process, we first need to configure the switch for inter-VLAN routing. We do this by creating a switch virtual interface, SVI, a virtual interface assigned to a VLAN. Each SVI is associated with one VLAN, so by creating multiple SVIs, we can facilitate communication between different VLANs. Next, we assign IP addresses to each SVI. These IP addresses serve as the default gateway for devices in their respective VLANs. It's crucial to remember that each VLAN must have a unique IP address. Once we've configured the SVIs, we enable IP routing on the switch. This step is vital as it allows the switch to route traffic between the VLANs. Now, let's move on to troubleshooting. If you're facing issues with inter-VLAN routing, there are several common culprits to consider. First, check if IP routing is enabled on your switch. If it's not, your VLANs won't be able to communicate with each other no matter how correctly you've configured your SVIs. Next, ensure that your SVIs are up and running. If an SVI is down, it could be because the associated VLAN doesn't exist or because there are no active ports in that VLAN. Another common issue is misconfigured IP addresses. Remember, each VLAN must have a unique IP address. If two VLANs share the same IP address, they won't be able to communicate correctly. Lastly, check your switch's routing table. If the switch doesn't know how to reach a particular network, it won't be able to route traffic to that network. With these steps, you can ensure smooth and efficient communication between different VLANs in your network. As we wrap up, let's quickly recap the key points we've covered today. We've dived deep into the realm of Layer 3 switching and inter-VLAN routing, two fundamental aspects of networking. Layer 3 switching, a vital process that blends the best of switching and routing, was unpacked, and we walked through the steps to configure and verify it. We then moved on to inter-VLAN routing, a crucial component in managing traffic between VLANs in a network. It was here that we delved into the nuts and bolts of its implementation and troubleshooting. Both Layer 3 switching and inter-VLAN routing are significant in ensuring the smooth operation of networks, and their mastery is a must for any network engineer. Remember, a well-structured network is the backbone of any successful digital operation. So keep learning, keep exploring, and keep innovating.